Continue talking about the law of sines, and specifically a case where you have two sides and an angle that's not between them. And that's called an ambiguous case because there's a possibility that you have 0, 1, or 2 triangles that you can make out of the two sides and the non-included angle. So here's a case where you've got an 8 and a 5 and a non-included angle that's 30. And that makes a triangle. But I could take that 5 and swing it around a little bit and put it here, and with the same information, 8, 5, and a non-included angle of 30, I've got a completely different triangle. There's two possible triangles there. Here, I've got 8, 4, and 30. And this 4, if I swing it around, it's only ever going to touch that one time on that third side. And here, with the 8, 9, and 30, if I swing that around, it's not going to touch that third side again. So there's only one possible triangle for these two cases. And in this case, I've got an 8, 3, and 30, and that 3 is not long enough to touch that third side at all, so there's no triangles there. So when you are given two sides and a non-included angle, there could be 1, 2, or even 0 triangles. So in example 1, we have to find out how many possible solutions there are for this triangle, ABC. When A is 28 degrees, side C is 50, and side A is 70. So here's how you tell. We're going to compare from this 28 degree angle, the opposite compared to the adjacent. Okay, so from this angle, opposite is 70, the adjacent is 50, so the opposite is greater than the adjacent. When opposite is greater than the adjacent, that tells me there is one possible solution. If opposite is less than adjacent, there's two possible solutions. And whatever we think the number of solutions may be, if I find a domain error when I'm trying to find one of the angles, then it turns out there's actually no solution. So now, for this same triangle, I want to find the solutions, which means find the missing angle measures and that missing side. So I'm going to use law of sines. So for law of sines, I have to have opposites. So I've got 70 over sine 28 equals, and the only other number I have is that 50, so I've got to use that, over, and angle C is what's opposite that, so sine C. Okay? So to solve this proportion, I'm going to do cross products. So I've got 70 times sine C equals 50 times sine 28. Okay, so I can get sine C by itself by dividing by 70. So I get sine C equals 50 sine 28 over 70. Okay, so to solve for C, I have to do the inverse, or arc sine. So it's arc sine 50 sine 28 over 70. Okay, so in my calculator, second sine, so now I've got arc sine, 50 sine 28, close those parentheses, divided by 70. And I get 19.593. And I'm actually going to keep all three, or I'm going to keep 3 decimal places here, 50.593, so 19.593. So for angle C, the measure of angle C, I've got 19.593 degrees. And I'm keeping maybe one more than I usually would because I'm actually going to end up having to use that number in my calculations as I go forward. So if I have to use a rounded number in my calculations, I want to use an extra decimal place just to keep it a little bit more accurate. So I've got 19.593 degrees here. So now I need to find the missing side limits. Well, I can find angle B first, actually. So in order to find angle B, I'm going to do 180 minus 28 minus 19.593. Okay, and that, if I type that in my calculator, it's going to give me 132.407 degrees. Okay, so I've got my other angle. And I'm going to have to use that angle in further calculations, so I'll keep that extra decimal. So, in order to find side B, I do B over sine 132.407 equals, and I can use 50 over sine 19.593, but I think it's just going to be easier to type in the calculator if I use 70 over sine 28. So I just need to multiply this across. So I'm doing 70 times sine 132.407 divided by sine 28. And I get 110.094. Okay, so now I've got all sides and all angles for that triangle. All right, so we'll draw a triangle ABC, 28 degrees. C is 70, A is 50. So this time, the 70 and the 50 have just traded places. So if I compare opposite to adjacent, this time I've got 50 compared to 70, and opposite is less than adjacent. So there are two possible solutions. So I'm going to split this and draw a second triangle because we're going to come up with two different solution sets. Okay, so first we'll start out by finding the measure of angle C. So 50 over sine 28 equals 70 over sine C. Okay, we'll do our cross products. So we get 50 sine C equals 70 sine 28, and we'll divide by 50. So now in order to solve, I just need to do arc sine of this. So second sine 70 times sine 28 divided by 50. Okay, 41.091. So C is 41.091 degrees. Okay, so that's my first piece of information. Now, I'm going to start the next one by using this. And then I'll come back and finish this side before I finish the other. Okay, so to get the other option for angle C, I find the supplement of 41.091. So that means 180 minus 41.091. Okay? And 180 minus 41.091 is 138.909 degrees. So that is the other possibility for angle C, 138 point, I didn't leave myself enough room. 138.909 degrees for angle C. Okay, so I've found a possibility for angle C on each triangle. Now I'm going to finish up this one on the left. Okay, so I can find angle B by doing 180 minus 28 minus 41.091. So I'm taking the two angles that I know away from 180, and that's going to give me 110.909 degrees. So for angle B, 110.909 degrees. Then for side B, B over 110.909 equals 50 over sine 28. Okay, so this should actually say sine 110.909. So let me erase that and start that over. So that's B over sine 110.909 equals 50 over sine 28. So I need to multiply this sine 110.909 across. So I'm doing 50 times sine 110.909 divided by sine 28. So I get 99.489. So that's my missing side here. So now I have all three sides and all three angles here. Now over here, I found that the option for angle C is 138.909. So for angle B, I do 180 minus the two angles that I now know, 28 and 138.909. So when I subtract those two angles from 180, I find that that angle B is 13.901 degrees. And the only thing left missing is side B. So B over sine 13.901 equals 50 over sine 28. So I multiply that across. So I'm doing 50 times sine 13.901 divided by sine 28. 25.587. So I've got all three angles and all three sides for this option. Okay, so there are two possible solution sets for that triangle. All right, triangle MNP. M is 25 degrees. Side M is 6, and side P is 8. So we compare opposite to adjacent, and that is 6 compared to 8. Opposite is less than adjacent, which means, again, we have two possible solutions. So I'm going to draw a second triangle for a second solution set. And I'll begin by doing 6 over sine 25 equals 8 over sine P. Okay, so I do cross products, and I get 6 times sine P equals 8 times sine 25. I can get sine p by itself by dividing by 6. And then in order to get p by itself, I can do arc sine. So second sine 8 sine 25 over 6. So I get an angle of 34.2975, so 0.298. So angle P is 34.298 degrees. I'll use that just to get a start over on the second solution set by finding the complement, or the supplement, of angle P. So P is 180 minus 34.298. And 180 minus 34.298 is 145.702 degrees. So that's the other possibility for angle P, 145.702 degrees. Okay, so I've got both possibilities for angle P. From there, I will go on to find angle N and then side N for each triangle. So for angle N, 180 minus the two angles that I know, 25 and 34.298. And that gives me 120.702 degrees. So there's angle N, 120.702 degrees. So side N over sine of 120.702 is equal to 6 over sine 25. And I can multiply that across. So 6 times sine 120.702 divided by sine 25. So I get 12.207 for side N. So I now have all three sides and all three angles. So in the second solution set, I've already found the possibility for angle P. So now for angle N, 180 minus angle M minus angle P. Okay, so when I do that subtraction, I find that angle N is 9.248 degrees. So side N over 9.248 over sine 9.248 degrees equals 6 over sine 25 degrees. So I multiply across. Sine 9.248 times 6, and I've typically been doing that 6 in front, so I'll do it that way again. 6 times sine 9.248 divided by sine 25. 2.282. And I actually did my subtraction wrong here. That should be 2.298, which is going to change my calculations here. So I'm going to have to redo that. 6 times sine 2.298. 9.298. Divided by sine 25. So I get 2.294, and that's where I should be. Okay, so now I've got all three sides and angles for two different possible solution sets.